Welcome to aminacademy.com. In chemistry, let us discuss about changing states. What are the 6 changes of matter? First is melting, changing from solid to liquid. Freezing, changing from a liquid to a solid. Here, if freezing is here, melting is this side. Vaporization, changing from liquid to gas. Here is a vaporization, and condensation is changing from gas to a liquid. This side, condensation. Deposition, changing from gas to a solid. This deposition. And sublimation is changing from a solid to gas. This sublimation. Let us discuss further detail about these things. A state of matter is the configuration of a certain material. This can be solid, liquid, gas, or plasma. Now that we know what is the state, we can study the meaning of change of state. What is change of state? Is the process of turning from a solid, liquid, or gas into another one of those states. Materials will change state depending on how much energy they receive or lose. With an increase of energy in a material, the average kinetic energy of the atoms begin to increase. That means if you give a heat to a material, the average kinetic energy of the atoms begin increase, causing the atoms to vibrate more, pushing them apart to the point that they change their state. The fact that kinetic energy changes the state of materials makes this a physical process rather than a chemical one. And no matter how much kinetic energy is put into or taken away from the material, its mass will always be conserved and the material will always stay the same. That is, mass will not change while the change of matter happens in condition. Change of state and thermodynamics. So we know what happens when a material changes their state, but why does this actually happen? Let's look into the thermodynamics aspect of changing states and how energy plays a part in this. More energy put into material will resulting in the turning into a liquid or gas, and energy being taken out of the material will result in turning into a liquid or a solid. This of course depends on whether the material is starting as a solid, liquid, or gas and what the exact environmental conditions are. For example, if a gas loses energy, it can turn into a liquid. That means a gaseous state, if lose energy, it becomes gas. It becomes gas that lost energy. It can turn into a liquid, and if a solid gains energy, it can turn into a liquid as well. This energy is typically introduced into a material via an increase in temperature or an increase in pressure, and both of these variables can cause different changes of state. The main causes of state of change are pressure and temperature. Here in gaseous state, the molecules are far away and liquids more nearly than gaseous state, and solid is very near. That means it's touching together like. A change of state occurs through a loss or increase of energy within the molecules of the material, usually through a change in temperature or pressure. Example of change of state. Below, let us discuss some examples for change of matter. First, freezing. Freezing is the change of state that occurs when a liquid turns into a solid. That means you are keeping a glass of water in a freezer, a deep freezer, it becomes ice. So it's called a freezing. A good example of this when water turns into ice. As the temperature decreases, the water will begins to lose energy until each water molecules no longer has the energy to move around other water molecules. Once this occurs, the molecules from a rigid structure that is kept rigid by the attraction that occurs between each molecule, we now have ice. The point at which freezing occurs is known as the freezing point. That means water freezing point is 0 degrees Celsius. We know that. Melting. Melting is the change of state that occurs when a solid turns into a liquid. Melting is the opposite of freezing. Using our previous example, suppose glass of water, it becomes ice, was subjected to higher temperature, it would begin to absorb the energy from its warmer surroundings. That means you are heating the ice. That means we are keeping the ice in outside the freezer, so it absorbs surrounding the warmer surrounding heat, and it becomes start melting, which would in turn excite the molecules within the ice and give them to energy to move around each other again. We now have a liquid again. The temperature at which a material melts is known as the melting point. Normally we know that the melting point of ice is at 0 degrees Celsius. Its temperature increases, it starts to melt. When the temperature scale for Celsius was first made, the freezing point of water, that atmospheric pressure, was taken as the 0 point, and the melting point of water was taken as 100 points. Here degree Celsius scales and Fahrenheit scales are produced. Evaporation is the change of state that occurs when a liquid turns into a gas. When a material is liquid, it is not entirely bound by the force of attraction, that is loosely packed between molecules, but the force still has some hold over them. Once a material has absorbed enough energy, molecules are now capable of freezing themselves from the force of attraction entirely, and the material turns into a gaseous state. Molecules fly around freely and are not affected by each other as much anyone. The point at which the material evaporates is known as boiling point. For example, boiling point of water is 100 degrees Celsius. Condensation is the change of state that occurs when a gas turns into a liquid. Condensation is the opposite of evaporation. When a gas enters an environment of a lower temperature or encounters something of a lower temperature, the energy within the gas molecules begin to be sapped by the cooler environment, that is absorbed. Energy is absorbed from the gas, causing the molecules to become less excited as a result. Once this happens, they begin to be bound by the forces of attraction between each molecules, but not entirely. So the gas then becomes a liquid. A good example of this is when a piece of glass or a mirror fogs up in a hot room. That means the vapor or steam in a room is a gas, and a glass or mirror is a colder material in comparison of that gases. Once the vapor hits the cold material, the energy within the vapor molecules is sapped out and into the mirror. That means the liquid parts are on the mirror, warming it slightly. As a result, the vapor turns into liquid water that ends up directly on the cold mirror surfaces. Droplets of water. It looks nice. Next, sublimation. Sublimation is different from the other changes of state that we have previously gone over. Usually, a material needs to change state one state at a time. That means solid to liquid, or liquid to gas, or gas to liquid, or liquid to solid. However, the sublimation forgoes this and has a solid turn into a gas without having to turn into liquid. That means solid becomes directly gaseous. That means it's a sublimation. Sublimation is the change of state that occurs when a solid turns into a gas. This occurs when the increase of energy within the material to the point where the forces of attraction between the molecules are entirely broken, with no in-between phase of having to be liquid. In general, the temperature and pressure of the material would have to be very low for this to occur. The process of sublimation, white fog, is the consequence of condensation of water vapor in the cold, sublimated carbon dioxide gas. One more example of sublimation is naphthalene balls. Suppose we are keeping a naphthalene ball in open area, it directly goes to a gaseous form. That means it mixes with the air of the room or the surface. Deposition is the opposite of sublimation. Deposition is the change of state that occurs when a gas turns into a solid. An example of this is when frost is formed. As the water vapor in the air or a very cold day will encounter a cold surface, lose all its energy quickly and change its state to solid, a frost on the surface, never having turned into water. Changes of states and the particle model. The particle model of a matter describes how molecules within a material will arrange themselves and the movement in which to arrange themselves. Each state of matter will have a way in which they are formed. Solids have their molecules liquid up against one another, the bond between them strong. The molecules in liquid have a looser bond between each other but are still bound, just not rigidly, allowing for a wider degree of movement. They slide over each other. In gases, this bond is entirely broken and individual molecules are able to move completely independently of each other. Here, look at this diagram is a good example for change of matter. That is, here suppose here liquid, solid is here melting, it become liquid, and evaporation it become gases, and come back gas to solid is a deposition, and here gas to liquid is condensation, liquid to solid is freezing, and solid to gas directly is a sublimation. Next, plasma. Plasma is one often overlooked state of matter, also known as the fourth state of matter. When enough energy is added to a gas, it will ionize the gas, forming a soup of the nuclei and electrons that once were paired up in the gaseous state. Deionization is the reverse of this effect. It is the change of state that occurs when a plasma turns into a gas. It is possible for water to be put into the three states of matter at the same time in specific circumstances. So far we discussed about change of matter detailing. We have done. Please subscribe our YouTube channel.